Okay, so just kind of like a quick background in case you're not familiar with Symbiont. We're actually one of the old timers in the industry. The company actually was conceived back in 2013. The platform launched in 2014. Quick background there is that our co-founder, Mark Smith, serial entrepreneur in Wall Street, he met Adam Karlstein, one of the pioneers in blockchain. Mark had like his claim to fame was when he sold a company called Lava FX, which was a multi-dealer FX platform. He sold it to Citi in the mid 2000s for over $300 million. Adam, in 2012, and since we're talking about DeFi, it's actually like this is really cool, interesting fact. In 2012, Adam built something called Counterparty. That was the first protocol that rode on top of the Bitcoin network to enable smart contracts on Bitcoin. So we're talking about like something like way before its time. So this is actually like, for example, for those that are not familiar, something like Tether that runs on top of Bitcoin uses a protocol like this. So Adam created this in 2012. This went live even before Mastercoin, which is considered also one of the initial protocols that rode on top of Bitcoin. And when he met Mark, they decided, let's do something for enterprises. Let's do something that is actually compatible with the existing regulatory framework and the security requirements that corporations will need. So the first thing that they said is, we need something that would be permission. We need a permission network so that the entities running the infrastructure and carrying out the transactions are known entities. So this was definitely kind of like a big turn for Adam, having essentially been doing DeFi to a certain extent, essentially like 8 years before the DeFi summer. But it was a new challenge. Back then, there was no reference architecture. Ethereum didn't launch until 2014. So essentially, Ethereum launched roughly at the same time as Symbiont came out. The Hyperledger Foundation was conceived until like 2015. So Hyperledger Fabric didn't exist. So our architecture remained very unique. And for reasons that I still don't understand, nobody copied our architecture. Maybe it's because we kept our architecture initially very essentially we kept our cards close to our chest. But it's interesting because it's once you, and I can even like go into the architecture afterwards in one of the break rooms, but once you understand it, it's simple and it makes sense. And it's something that a normal person, like a non-technical person, can understand why it's so powerful and scalable. Here you can see our board of directors, a bunch of people that used to be in government and in Wall Street. So we have a regulation-first approach, which is also what inspired the platform. So I'm just gonna like jump through this, but essentially in talking to clients, I run into a lot of situations where people don't really understand when to use blockchain. They're using blockchain for the sake of using blockchain, and I've gotten answers that's like, well, we're using blockchain because we can issue a token and raise funds that way. That is a token ecosystem waiting to implode. Blockchain is useful whenever you have essentially multiple contributors all writing to the same ledger, and you need all of them to coordinate that data. And usually if you're writing data, there's going to be some workflows and dependencies around that. There's going to be different logic. And you're also going to need potentially third parties to look at that and trust the data. And the whole point of this whole distributed database is to avoid any trust issues. That is when you can use blockchain. The Satoshi paper back in 2008, it has 0 mentions of blockchain in it. It was aimed to be a very simple peer-to-peer electronic hash system. That's it. It was using hashes of digital timestamp, using proof of work consensus. A lot of the technology that it cites was actually from years earlier. If we look at the references, B-Money, if you look at what B-Money was, this guy, Wei Dai, came up with something that looked and felt exactly like Bitcoin by 10 years before. It just was never implemented. It never made it like past the drawing board. Hashcash was essentially using what we know today as proof of work as a way of preventing spam on emails. So these were when emails were, we're talking like early 2000s. So email had been around, starting to get to the point where like spam was an issue, and using proof of work was a way of avoiding spam. The other stuff you're going to see here, a lot of it is related to timestamping, so digital timestamps, so you can have an auditable trail. And then, of course, we have some stuff related to Merkle trees and Merkle proofs. And of course, probability is always important in this type of stuff. Just want to clearly differentiate between centralized, distributed, and decentralized. Centralized, we'll know what it is. You have a database with one admin. Distributed is you may have actually multiple databases, but there's a single admin. And then decentralized is when you have multiple databases, which in this case really are nodes, each of them with a separate admin. That is true decentralization. So if you have multiple nodes, but the same party is running all of them, that is distributed but not decentralized. And I think in the industry, there's a bad habit of using the terms indistinctively, and it actually means it's very relevant to understand that. Also, another thing that is highly overlooked is these data considerations here. Just gonna kind of like explain very quickly what it is. Robustness of a system means that you build it, you beef it up enough so it's actually, it can look at all the corner scenarios so it never goes down. Resiliency is actually a system that is built such that parts of it can fail and it can continue working. So those are the type of things that you want in a blockchain. Integrity versus consistency. Integrity simply means that you know that the data was not changed. Well, consistency means that everybody that is able to see the data sees the same value. So very different things. Availability, it means that the data is available to people that want and are able to see the data. Well, accessibility is how easy is to see the data once you can see it. So that is those are important considerations when you start looking at permission architectures, and also some of the public architectures in which you have specialized nodes that may have different access than other nodes on the network. So Vitalik Buterin, the founder of Ethereum, came up with the blockchain trilemma back in 2015. The whole idea that blockchains have always need to make trade-offs between security, scalability, and decentralization. The scalability is the property of a system to increase linearly as you increase essentially the throughput through it. Decentralization is ensuring that a system cannot be controlled by a minority. Security means that the system is used as it was intended. So people love grabbing different blockchains and putting them along some of the sides of the triangle to figure out, okay, what are the trade-offs here? And then once you start like bringing in the permission blockchains, things just fall apart and you don't really know where they fit. And of course, at Symbiont, we like to claim that we actually have the perfect like trade-off between all three. I hate the trilemma because it does not teach anybody, especially the people new to the industry, what are the true characteristics. So you could argue that you need another area, you could break out privacy, but once we go into this, then you could break out a fifth vertex that talks about scripting and functionality. So that's just the wrong way to see it. So this is the way I see the world. I see it starting as a very simple state of the world where we have like 4 different types. What I call state machine replication. A state machine in computer science, it's essentially something that follows a logic. For the same inputs, it always arrives like to the same outputs if you apply that same logic. In a state machine that happens to be replicated across many nodes, you would expect that for the same behavior, for the same inputs, you reach the same behavior. The classical example in computer science is if you have a vending machine, you put a coin, you choose the Coke, and it gets you a Coke, period. And then the machine resets and it knows that next time it gets a coin, it can give you a Coke. Now, if you have 50 of these machines all over the US, anywhere in the US, if you put the coin, then you should be able to get a Coke just like it works in the other 49 machines. With blockchain, the way this works is that you're putting the coin, but you're telling all these machines on the consensus layer, they all agree that a coin went in. So they all go and they calculate, and then they give you that Coke in all the machines. Of course, we're talking now about digital records in this case, but the idea is that you are not following a master slave modality like you do in traditional databases. Rather, in this case, what you're doing is you're ensuring that all the nodes arrive at the same result by performing the same calculation. And all you're doing is agreeing on the logic and agreeing on the inputs. So that is the traditional blockchain. So Bitcoin, Ethereum, Cardano, Litecoin. And you could argue that Cardano is a bit different because of the consensus, and I can get into that in the breakout session. Then we have the permission blockchains, like Assembly in 2014. Later came JP Morgan with its Quorum network. Nowadays, we also have Hyperledger Besu, which also lives under the consensus umbrella. These are the ones that went on a permission approach, and they implement privacy in a similar way. Then we have the semi-permission ones. So these are the non-blockchain DLTs. So we have Corda and Hyperledger Fabric. In the breakout section, again, I can explain why these are technically not permission blockchains, but a lot of it is that they have specialized nodes and they do peer-to-peer sharing as opposed to replicating across the whole consensus layer. And last but not least, we have the public ones that decided to do some level of centralization for the sake of better performance. So this is where you have EOS, Tesos, Algorand, etc. They're all some type of distributed proof of stake network. This is the super high level. You need to then like the first thing that people are gonna yell at me is like, well, like you have the public coins and stuff like that. So I'm happy to go to this into the breakout session. I just don't want to abuse the time that I have here. Same thing with public information. Like we can go this in separately. The main thing that I want to do now is essentially split this between the simple scripting blockchains and the public ones, the ones with smart contracts. So you have to essentially split whatever is like Bitcoin and Litecoin from Ethereum and Cardano. Because so if we're talking about scripting, we got to talk about different languages. The main thing in which you divide the world are the general purpose languages. So the traditional ones like C++, Java, Go, JavaScript, etc., and the domain specific ones. We're talking about Ethereum, which is the language, Solidity, the language behind Ethereum, Plutus for Cardano, YAML for digital assets, and Simple for Symbiont. There's pros and cons of using a general language versus a DSL. In general, the general language is familiar. The issue there is that it is not built for a distributed paradigm, and you may run into consistency issues if not used properly. So essentially, even if it works, there's a high likelihood that an amateur developer will shoot themselves in the foot. Domain-specific languages try to build in certain guardrails, and also usually the ones that are specific for an architecture, they're going to exploit to the max the underlying architecture. So last but not least, until I finish this, and by the way, this presentation is literally like 45 slides, so I'm just cutting it short, and I'm happy to go into more detail after. So I want to finish the framework only. The privacy coins. So the privacy coins, if we're talking about Monero, Zcash, and Dash, they are private in the sense that they provide privacy of simple token transactions. That is not to be confused with the complex privacy that can be offered by a platform like Assembly in Symbiont. That includes privacy that you can actually have documents, attachments and channels, etc., and a bunch of other things. That's why I think like when you look at this framework like this in these 6 broad categories, you can not only come up with a mental framework of how to split these things, but also you're seeing a trend here. I walk you through the history of how all these different blockchains evolve through time, so you can understand where things are going next. This I think like sets both like the categorization, but also the evolution of the blockchains. And again, I could go into more detail on privacy and all that, but I'm going to stop here so we can have other conversations. I'm happy to chat on the breakout.